Hi boys, that we are almost done with circles. I suggest printing this note sheet out just because it's a lot to write down and a lot of diagrams to draw. And we are just talking about that when segments or chords intersect within a circle more specifically, what that math can look like. So if we're looking at two different chords that are intersecting at point E within the circle, I can conclude some information about that. I can say that AB and CD intersect at point E. Therefore, EA times EB, so the different sections of AB, are equal to DE times EC, the two different sections of the other chord. It's just some cool math that works out. Other types of lines that can intersect in a circle are secants. So if we remember, a secant runs through different parts of the circle, and a secant segment is a segment that contains a chord of the circle. So a chord of the circle would be this black and has exactly one endpoint outside of the circle. So this red scribble would be that where that one point is outside of the circle. And the other part of the secant segment is outside of the circle. So this blue section here. Really what you just are looking for is images that look like this for the math. The other type of image, I put these out of order. I guess I should move these around. Is segments of secant. So we have one segment EB and ED, and they both intersect at point E. I can say that EA times all of EB is equal to EC times all of ED. And the one that I should have put that's out of order, this section here, goes along with this image. I can say that EA squared is equal to EC times ED. It's a lot of just matching up what does the diagram look like, and so which one can I connect it to. So for part A, I would notice that this goes with the first example, so we would be using this type of math up here. So what I'm allowed to say to figure out what X is worth, BE times ED, 8, is equal to EC, 4, times X. And then you just simplify. We have 24, wow, not 32, 24 is equal to 4X, therefore X is equal to 6. So you're just setting up these two different sections of each chord are equal through multiplication. In part B, you would do the same thing, as well as C, and as well as D. I'm hoping that you can use the textbook or that one example to help you. For part E, we would be using this math section up here. So we're using a portion of that segment and the whole line, a portion, the whole line. So in this example, I would be able to say that 4, so the smaller section BC, times the entire length of CA, so 4 plus 6 is 10, is equal to 5 times the whole section, which is going to be 5 plus X. And then we're just going to simplify. So we have 40 is equal to, let's distribute, 5 times 5 is 25, plus 5x. Where did my typing go? 5x. Then when we subtract 25 from both sides, we'll have 15 is equal to 5x. And then finally, x is equal to 3. And if you're not sure if that works out, always plug everything back in to check if it works. So I'd be plugging in 3 here, and I would be wondering if 5 times this entire length of 5 plus 3 is 8. So does 5 times 8 equal 40? Yes. Does 4 times 10 equal 40? Yes. The last two examples deal with my out of order skills here. This last example, so you square the shorter segment, and it is equal to the shorter times the whole thing. So in this example, let's see, we have 2x. I'll do both with you because these are a little difficult. So we have 2x squared. So that whole thing, 2x, the whole thing is squared. So we square the shorter section, and it is equal to 9 times the whole segment length. So we have, in this one, it's going to be 9 plus 4, which is 13. And then we have, I'm running out of room, 4x squared. There is no really great way of me doing this if I do it quickly. Is going to be equal to 9 times 13, which is what, 117. Oops. We are not going to have nice math here, are we? And we want to divide by 4 on both sides. So we're going to have, yikes, I don't like that this is going to be a decimal. So I'm actually going to let you keep it as a fraction. So we're going to have x squared is equal to, let's insert the fraction so you can see what I'm meaning to do. If you have this happen, leave it as a fraction in its most simplest form. So we'd have 117 divided by 4. And then you would take the square root to get x by itself. So what that would look like is the entire square root of 117 over 4. And the only thing we can simplify is the denominator. So x would be equal to the square root of 117 over 2. And that's fine. Leave your answer as such. Of course, I have easier ones down here. Let's do those. Wow, I did the most obnoxious one first. Okay, we're skipping to k here. So we have x squared, forgot I made so many examples, is equal to 5 times the whole length of this segment. So we're going to have 30. And then we're going to have x. I'm sorry, we're not going to have 30. Hello, 11. X squared is equal to, so 5 plus 6 is 11. Hello, is 55. And then you want to take the square root, and you're going to have radical 55. Do not give me a decimal, just leave me a simplified radical. There's nothing I can do with 55, so leave it. If you want to keep watching, I'll do L, since I don't know why I started with that other one. My apologies. We're going to have x squared is equal to 12. So the section out of the circle times the entire section. So 12 plus 4 is what? 16. And then you're going to just multiply 12 times 16. And we're going to get, what is that? 192. So we have x squared is equal to 192. And then we're going to have x is equal to the square root. If it would let me insert, that would be cool. 192. And then I know that I can start to break this down. I clearly know that 16 and 12 work. If you want to think of other ones, let's think of other square roots really quickly. Let's see if 64 goes into this. I'm going to check. Oh, it does. Perfect. So I can break this down into the square root of 64 times the square root of 3. So we can start to simplify our answer. So 64. Always try and look for the biggest one. That just makes it so much easier. So then that would leave us with our final answer is going to be the square root of 64 is 8 times the square root of 3. And you're done. So just use this as a reference sheet. It's pretty self-explanatory on how to match up the math.